This is the third day. Just a lot of different types of these problems. We're going to continue talking about linear programming. But these are going to be story problems. And so, like I told you yesterday, the ones we had yesterday, they didn't really have any meaning behind them necessarily. The numbers were just, it was just random inequalities, equations that didn't really have anything behind it. Today, we're going to look at actually some situations or some stories where we could use linear programming to help us to maximize or minimize the situation and where you might see something like this used. I'm going to do two with you, kind of like I did yesterday, and then I'm going to assign just one problem, kind of like yesterday. All right, and so these are, once again, out of your textbook. If you want to follow along in your book, you can, especially since it's a story problem. The first one I'm going to do, it's on page 470. Number 68. Okay, so this first one is talking about a lumber company or a wood mill company. They convert logs into lumber and plywood. The mill can turn out 400 units of production, and at least 100 of those are lumber and 150 are plywood. So they're making two different kinds of wood, essentially. The profit is $25 per unit of lumber and $38 for plywood. How many of each type should the mill produce in order to maximize the profit? And then what is the maximum profit? Okay, so there's a lot of stuff going on in here. The hard part to these, obviously, is that there is no variable given to us. There's no equations given to us. So we have to take all that information, we got to put it together, and we got to be able to write the inequalities, and then we got to be able to solve it. The solving of it is going to be very similar to what we did yesterday, where once we have the inequalities, then it's going to look pretty similar. This first one, the graph's going to look a little bit different than some that we did yesterday too, which is kind of why I picked this one out. Okay, so first of all, we always want to identify the variables. The two variables here are lumber and plywood. That is what the factory is making out of the logs that they have. Lumber and plywood. Hey, one thing that I kind of like to do, just so I can kind of put it to the side, most of the time, not always, but most of the time when you look at these story problems, the maximum minimum function is going to be what they call the profit function. Because if I was a company, my goal is what's the maximum profit I could make based on the amount of lumber and plywood that I'm going to produce. And so I like doing that one just to kind of put it to the side and not use it till the very end and know that that's not part of our actual graph. So in this one, we make $25 profit for each unit of lumber, and we make $38 a profit for each unit of plywood. So that's one of the things that we're just going to kind of put over there to the side and leave it alone until we get to the end. Okay, I just kind of like to get it out of the way so it doesn't confuse us on the rest. Okay, now here's the part that is a little bit different than some that we did yesterday. It says that the mill is going to make some of each. So first of all, the total production is 400 units. So the amount of lumber plus the amount of plywood cannot exceed 400. So x plus y has to be less than or equal to 400. I can make less than that, but I can't make more than that based on time or supplies or whatever it is. But they're telling me that is the constraint that we're dealing with. We can make at least, or they must make at least 100 units of lumber. Probably because they have sold so much, they have to make at least 100 units of lumber to supply the people that are buying their stuff. it says that they also have to make at least 150 units of plywood. Okay, and so to kind of talk about these, first of all, this is my total production of the two different ones. That's pretty straightforward. These are going to be a little bit different. Like, we know they can't be zero, but not only can they not be zero, they cannot be less than or equal to 100 for the x values and then 150 for the y values. So it's even given us a bigger constraint. We can't go below that for those two values. So we know that we're still limited to the first quadrant. Okay, the first quadrant is where we got to be, because we're not gonna produce a negative amount of lumber or plywood. And so just like yesterday on the ones that we did, we know that our graph is going to be in the first quadrant. Okay, before we kind of decide like what our increments are going to be on the x and y axis, I think it would be good to go ahead and get our x and y intercepts here. And there's only one of them that we have to do that for. There's only one standard form equation. And both of them are going to be 400. Because if I plug in 0 for x and y, then both x and y are going to be 400. So you got some options here. We know we got to go up to at least 400 on our x and y axis. You can count by hundreds. I'm probably going to count by 50s, mainly because I see this one right here is 150. And so I'm going to count by 50s on both the x and y axis. So 50, 100, and we're just going to keep counting by 50s until we get up to 400. That's my x. Okay, same thing on the y-axis. 50, 100. Going by 50s. You don't necessarily have to label the whole thing. You can if you want, but. Okay, x has to be greater than or equal to 100. So I'm going to do the vertical and horizontal lines first. Vertical line is going to go through the x-axis at 100 based on this inequality. Now remember, it's going to be shaded to the right because it has to be greater than or equal to that. So remember where that would be shaded at. Same thing for the y value. The y value is going to be a horizontal line through 150. So right now, kind of like yesterday, we were kind of constrained to the first quadrant. Now we're going to be to the right and above these two lines because they're both greater than or equal to. And so that's why the inequality is a really big deal. We have to make at least that much. Okay, so that's a little bit different than some that we did yesterday. And then we're going to throw this last one into the mix here as well. 0, 400, 400, 0. Would look kind of like that. And that one's less than or equal to. We can't make more than that. Okay, guys, let's put our phones away back there, please. Okay, now think about where this graphing is going to go to. So these were both, we said, to the right and above. This one's going to be below, so we're in this little area. You should have a constrained area. We should have an enclosed area. If not, then my graph's either wrong or I've done something wrong. Okay, if it's not completely enclosed. So this would be the area that we're focused on. It's a triangle, right? So we have 3 points that we got to figure out. A little bit harder to come up with these points than what we did yesterday, but it's not too bad. This one should be pretty easy. What would this ordered pair right here be? 100, 150. Yeah, 100, 150. Okay, it crosses the x-axis at 100 and the y-axis at 150. It's where those two vertical and horizontal lines cross. So we're going to go 100, 150. Okay, and really these aren't too bad. You really don't even need your calculator for this because if I was going to, this one has an x value of 100 And if I put an x value of 100 into this equation right here, then my y value would have to be 300, right? So this would be 100, 300. And then the last one, here's the sloped line again. That's your standard form. My y value is 150, so what would the x value have to be? 250 to make 400. So 250, 150. So you just kind of have to pay attention to which two lines are crossing at that specific point, and that makes it a little bit easier. We only had 3 points to come up with yesterday. Or yesterday we did one that has like 4 points. We did one that had 5 points. This one only has 3 points. So every problem is going to be just a little bit different depending on the inequalities that you have. The last thing that we're going to do, we've already written out our profit function, right? We're going to take these 3 points and we're going to plug it into our profit function. So here's where we probably would want to use our calculator. 25 times 100 plus 38 times 150. Okay, 100, 150. You may get that one yet?
Yeah, I got 8200.
Okay. And this is profit, so this is money. So this lumber company would make $8,200 if they made that much in lumber and plywood. Okay, 100, 300.
13,900.
Okay. And then 250, 150.
13,250.
How much again?
I got 13,250.
Okay, that's what I got too. So I just want to make sure my numbers were right. Okay, it doesn't change my max. My max would still be here. So what we're saying here is if we were this company, right, and we're trying to figure out how much money are we going to make, this would be what I would choose. I want to make the most money I could make. And in order to do that, we would make 100 units of lumber. And 300 units of plywood. And that gives me a max profit of $13,900. Any questions on that one? Okay. So I picked out two that are similar, but yet a little bit different as well. Next one we're going to look at is on the same page. This one is number 66. We had to figure out how many of each kind was going to be made, right? And so it's not. Okay, this one, kind of the same idea, except instead of plywood and lumber, you got to figure out what are the two things that you're making. Okay, and this one's not going to be a 3-variable equation. Whenever we do inequalities like this, we're not going to do any that has like an x, y, and z in it. So there's only going to be 2 variables. We got to figure out what the 2 variables are. In this case, it says how many of each size of biscuit are we going to have to make? Well, we have 2 different kinds of biscuit. We have the jumbo biscuits, and we have the regular biscuits. So that's always going to be the first thing that you got to do. Because when I write my inequalities and equations out, they're going to have an x and y in it, and we want to know what those x and y's represent. Okay, that's a really big part of what we do. So always start off with identifying what the variables are. Kind of like the story problems that we did last week as well. Identify what those variables represent, so when I get my answer at the end, I know what each one represents. Okay, the oven can cook at most 200 biscuits per day. Each jumbo biscuit requires 2 ounces of flour. Regular biscuits, only 1 ounce of flour. There's 300 ounces of flour available. The profit, you don't necessarily have to do the profit first, but I kind of like to do it. So I'm going to say P equals each jumbo biscuit makes 80 cents in profit. Each regular biscuit makes 50 cents in profit. Okay. And like I said, I like to do that kind of at the beginning and not let that confuse me when I rewrite all the inequalities. This is not something that we're graphing. We're not doing anything with it until the very end. So that's why I like to do it and get it done and get it out of the way. Okay, the oven can cook at most 200 biscuits per day, but we don't know how many of each one, right? So we could do like 100 and 100, which is what a lot of people probably would think, but it's not necessarily going to be the same amount. Kind of like the last one that we talked about, necessarily going to be the same amount of each, especially because I'm making more of an income or profit off of the jumbos. So ideally, we'd probably want to try to make more jumbos if it works out that way. And it may not, okay? So if I can make at most 200 biscuits, what would be the inequality that would represent that? Yeah. X plus y less than or equal to 200. Okay, some combination. And I could make less than that, okay? Probably wouldn't, because I want to try to maximize it as much as I can. So you're probably going to make some combination of 200 biscuits, but we just want to figure out what are all the different combinations I could do. Okay, the second one talks about the amount of flour being used. The jumbo biscuits require 2 ounces of flour, so 2 ounces for each biscuit. The regular requires 1 ounce of flour, and we have a total of 300 ounces that we could use. Once again, I can't go over that, so 300 would be the max amount I could use because that's all that I have available, but I could be less than that. Okay, so less than or equal to. Okay, and then the last two inequalities, they don't give us any other restrictions, but we can't make a negative number of biscuits, right? And so probably wouldn't be a bad idea to go ahead and identify these two as part of our group of inequalities as well. The lowest number of jumbo or regular biscuits I can make would be 0. Okay, if I choose to make all of one type, 0 would be something I could make, but I can't make negative. So once again, we're going to be limited to the first quadrant, almost always, especially on these story problems. Which tells me that we're going to just deal with the first quadrant again. Okay, for the first inequality, it's kind of like the one we did earlier. Because these are just x and y and there's no coefficients there, then my two intercepts are going to be at 200. For the second one, if I plug 0 in for x right here, my y-intercept would be 300. If I put 0 in for y, cover this up, 300 divided by 2 would be 150. And I don't really care what you use for your scale here, but once again, I would probably go in increments of 150. This time we only need to go up to 300. And we only need to go up to 300 on the y-axis if you really want to be exactly right? Because the X values only go up to 200. So you can go up to 300, but you don't really need to. So 200 and 200 would be the first line. Okay, 0, 300 would be up here on the y-axis. 150 would be down here. Once again, we are constrained to the first quadrant. So we're going to be in this little area right here. Okay. So how many points are enclosing that little area? 4. Yeah. We got this guy, we got this one, and this one. Okay. 3 out of the 4 are pretty easy to come up with. And this is kind of similar to one we saw yesterday. 0, 0. 0, 200 on the y-axis, 150 and 0 on the x-axis. And then this is the one, we don't just want to guess what that is. We got to be pretty accurate with what it would be. So what would be the best way to find that one? Where those two lines cross. You can do substitution, you can do elimination, but what would probably be our go-to? Matrix, okay? So our matrix that we're going to put in would be a matrix of these two, because these are the two lines that are crossing right here. So we're going to go 1, 1, 200. And then we're going to go 2, 1, 300. That will give us our 4th point. Let's see where they cross it. What'd you get, Aubrey? 100. Okay. And you can tell that's why you don't want to go off of your graph. Mine's off just a little bit. It looks pretty close, but because I freehanded, it's not going to be perfect. And so that's why you don't want to go off of what the graph looks like. Okay. If I were to get a ruler out and draw it a little bit better, I'd probably do it. If I did it on a piece of graph paper, it would probably look a little bit better. Okay. Now, if I was going to make a profit, would making 0 biscuits give me a good profit? No. That would give me a profit of good old 0. So probably not going to make 0 biscuits if we're going to make a profit at this. Okay, 0, 200 would be really just 50 cents times 200, which would be $100. Okay, if I only make jumbo biscuits, then that would be 80 cents times 150. What's that give me? $120. Okay, and then if I make some of each, we'll do 80 cents times 100 plus 50 cents times 100. So that would be 80 plus 50, which is 130. And so that would be our max profit. And in order to get there, we'd have to make 100 of each. doesn't seem like much of a profit, right? So it's probably not a very large company. But that's per day too, so $130 a day profit. if that's- Okay. Story problems, lots of fun, right? Okay, the problem that I'm gonna assign to you here is just one problem. You can just add this. And that's the one problem I'll assign for today. So, like yesterday, you could add yesterday's problem to the end, and then add this one to the end, and so you can put all of this lesson all on one assignment. Okay, if you want. All right, I'm going to pass back the quizzes. Let you correct. If you want. I have not put them into the grade book yet, so once you guys get them corrected, if you want to correct them, then.
When I got this one right now. So which one is that?
You got a bonus problem,
Me? Yes. I'm sorry.
Where'd you get it?
Okay, probably the ones that were missed the most. Number 8 was missed quite a bit. I think we just have a hard time knowing which one's which. But once we decide what type of system it is, then all you got to do is remember